The next part of the thing to go together is, of course, the little 5.8 gig module. We're going to have to put this onto the board now, and it goes on the back of the board. So this is the side that's got all the components on it at the moment, but this module goes on the back, and you have to work out which way it goes. You'll notice that on one side there's a little gap in the tin, and the little tin cover. On the other side there's no gap. That little gap there is where the antenna connection comes out. So you can see that one of these little connections here is the antenna. In fact, it's this little one here. It just has a little short lead to nowhere, and that's the way it goes. So that lines up with the little short lead to nowhere. So one thing you may find is that after soldering in this capacitor leg there, and there's another capacitor here, you may have to take a file to these, just file them down a little bit so it's flat, because otherwise they'll try and dig into the little circuit board we're putting on here. But one thing you can do to reduce that is put some double-sided tape on the back of the module, which is what I'm going to do here. That will just suspend the module a little bit above the circuit board. So we can just lay a bit of double-sided tape on here, just wide enough that it misses the contacts, because we don't want to get it all melted and so forth when we solder it up, and then just cut that off. Oops, this is the foam double-sided tape, of course. It's got a foam layer in there, so that when we put this on the circuit board the correct way around, it's actually sort of spaced out slightly. We can push it down to make some contact, but it means there's an insulating layer between the board and the circuit board underneath. And what we will do is we want to actually make sure that's pressed down fairly hard, so we'll solder one little edge and then we'll push it down and solder the other edge, and then go over and solder all the bits and pieces. But before we do that, we have to tin these little lands here if we're making a board ourselves. If you've got a commercial board, it'll already have some solder on there, or it'll be silvery on there, or goldy, and so you might want to add a little bit more just so it's easier to solder this board in place. I'll do that now at the risk of boring you all, because this is a bit of a tedious operation. It doesn't look good on the video. Now some of these we're going to have to run wires through. So with those ones I'm going to put a piece of wire through there so it'll join onto the top surface of the board. And sources of that wire are actually the legs we cut off our other components earlier. We can actually put a piece of wire through like that, and we'll solder it on both sides so that it connects the bottom to the top. As I say, on a commercial board you don't have to worry about that because it'll be plated through those holes. But I'll just run it through the ones that I need to on here. As you can now see, I've soldered a number of bits of wire through the board so they poke right up where the module is going to sit on the back. So they come from the component side through to the back, and that's all these little pins here that connect up to the module, so that I can now take the module and lining it up so that the little gap there goes towards where the antenna is going to be. I can slide it into place. Might have to spread some of these wires out a bit so that you can actually slide it down. Slide it into place, making sure that everything, of course, lines up. Put my granny glasses on for this one. Try and keep it all in shot while I'm doing it, because you'll find the module has some little holes there for the wires to go through. Now, so it's a bit fiddly. You might have to just bend them in and out a bit just to get to fit. This one was done by hand. It may not be as accurate as the one that you'll get if you buy commercially. So here we go. So now I've soldered that module on the back. As you can see, I've soldered the wires. And now this is only required, these extra bits of wire here are only required when you use a homemade board. If you do buy the commercial board, then you can just solder this flat onto the circuit there, because these will be plated through holes. We won't have to put wire through them to connect the top copper to the bottom copper. It's automatically done by the people that make the boards, which is great. So now we're getting pretty close to being finished. What we have to do now is take our pin headers, which I've got in my box here, these pin headers, and put them in these holes along the bottom. Now we need to do that because we're going to be connecting all the wires for our backpack. The camera, the UBEC and the 12-volt supply will all connect through these holes. Now we could just simply put the wires in there and solder them on, but because some of the soldering has to be done to the top, although if you've got a commercial board it's not a problem, but when you're doing a homemade board, putting a pin header in there, just one of these pieces of wire, and then soldering the wire onto that, makes for a result that's less likely to suffer from wire breakage due to flex, and I'll show you why that is. So what we've got to do is get 1, 2, 3, 4, 5, 6 pin headers out of this strip, and that's pretty easy to do because these actually sort of slide out of here quite easily. Now you could use, see that? Just pull that out of there. You could use thick bits of wire like I did for the module. These are a lot stiffer than thick bits of wire, that's why I use them. These are actually quite strong. Copper wire bends way too easily. These are really, really tough, so they won't bend, and we don't really want them bending because that could result in stress and failure. You know, you get the old metal fatigue setting in. So these little pin headers are a much better way to go. 1, 2, 3, 4, 5, 6. How many do I need? One more. And there we go. So you see I'll pull them out of there. And now what we have to do is actually put these pin headers into the board through these little holes. And hopefully the size of the hole is just right. These ones, I've drawn these a little bit large actually. I should have left them a bit smaller so they're a tighter fit. But what we do now is basically solder these into place. And we want them so they're pretty much entirely through the board, only a little bit on the back. Try and keep them roughly the same length. So we've got maximum length to solder our wires to. And it's not going to be so easy because these capacitors are a bit high, but I'll go ahead and I'll solder these on. Just position the board so we've got something supporting the back of that pin header, and I'll solder it onto the top surface first because it's easier in this case. A bit of heat into there. There we go. So we solder these on both sides because we want maximum physical strength. So I've soldered the back side. Oops, solder this side. Drill the holes so that they're a tight fit. Unfortunately, I drilled these holes a fraction too large, so they tend to fall out, which makes soldering them a little problematic. So there we go. I've now soldered all those pins on there, as you can see, soldered them. If you've got the commercial board, you only have to solder on the bottom, but solder them on the top as well gives extra strength because that's where our wires are going to connect, and we need those pins not to be easily wrenched out by loads that might be put on the wires. And we're getting very close to finishing now, as you can see. So what we'll have to do now is put the wires on here and mount the antenna over here. That's the only two things left to do. Notice there are some unpopulated. There's two components I've left off there because, as I mentioned earlier, that's for the microphone. If you don't want audio, leave those off. In fact, you wouldn't have to put one of these pins in as well. It connects up to that, but I just do it that way, and as I say, I don't use a microphone. So now let's get on and do the antenna, and to do that we've got to sort of cut away a little bit of the insulation on the end of our antenna. Preferably no more than 5 or 6 millimeters should be heaps, because we've cut this to length, so it's a fraction of a half a wavelength, or it's a multiple of half a wavelength, which means that we get the best, or we don't have to worry too much about our antenna being not 100% perfect. We won't get quite so much in the way of reflected losses along the cable. So here we go. There we go. So I peel off that insulation on the end and just splay out these wires here. The outer shielding, just give that a little bit of a tweak so you end up with a wiring going on each side of the insulation in the middle. Make it into a kind of a cross, and then you've got to just cut back that center insulation a little bit. Try and get this on the camera because it's a bit like so. You can pull it out. This is not too dissimilar to when we were doing the actual other end of this antenna. So now here we go, and we have to make sure there aren't any stray wires that are going to get in the way, because that can happen. I hope I'm in shot because I'm actually looking closely. Then we just tin this up as we have done before. I'm working backwards here through the camera. It's a bit of a trick. Here we go. Just tin this up if I can. There we go. And I'll just tidy up that. There's a few loose wires hanging around here. Do the same here. Get these. It's a bit hard to see. I should stop complaining, shouldn't I? And just do it. Don't even know if I'm in shot here. Soon find out later. Right, so there we go. Excuse me. And now we have to mount this on our circuit board like so. in order to do that, we're going to have to sort of tin the edge of the board so that the braid will be able to solder just to the edge of that board, and then the aerial part itself will solder onto that second pin from the end. So I'll endeavour to do that now. So we don't actually use that piece of copper that we've soldered the board to with the antenna piece. That's not actually used. Alright, there we go. Right, that's one piece of wire soldered down. Soldered down the other side. Try and get the antenna straight. It always looks better if it's straight. It's not totally straight, but it's near enough. Now just position the wire so that's right on top of that. It's actually a bit long at the moment, so I'll cut a little bit off. You want to try and keep all the stuff as short as you possibly can, because with radio frequency stuff, any extra length actually reduces the performance. Right, I think that's soldered. Give you a close-up on this if I can. Get some focus out of this. Here we go. So there you go, you can see how I've soldered that to the module. It's our antenna. Our backpack now has its antenna on there. So now we've got to put the wires on for the camera and everything. Again, we have to go back to our, let me just clear up a bit here, go back to our little diagram to find out which pin is which, because what we're going to put on now is the video connector from the camera, which is that other extension that we made. So I'll just split these wires a bit. You can use your fingernails, you can use your side cutters, but if you've got fingernails that work, you can just spread these apart with your fingernails. You have to pare them back far enough that you can actually put some heat shrink up here on the wire while you're soldering it to these pins. And of course we've got our heat shrink sitting here. We just need a length that's long enough to go over these pins and a little more. I'm just trying to get some focus on here. Oh, I'm really having trouble getting this stuff in the right place on the camera. Okay, so I'm going to make the heat shrink about this long. You need to make an extra 5 to 6 millimeters past the length of the pin in order that you get some support on the wire and it won't fray and break. So I need 3 of those for the camera. Because we've got video, power and the earth. So they should be roughly about the same size. Here we go. 3 of these roughly the same size. And they'll go on there. Now the other thing we need, of course, is the UBEC. Remember I mentioned that we're using a UBEC here to reduce the voltage down from the 3-cell pack to 5 volts to run this little regulator, which then drops it down to 3. So we'll get the UBEC and we'll start wiring that in as well. Okay, I've pulled these wires back far enough on the little extension lead that's for the video. Pulled them back far enough so that I can allow enough here just to pull some insulation away, like so. I use my fingers, you can use side cutters, but I've been doing this for years. We can pull that away, we can tin this up, and it means that when we put it on the pin, the heat shrink isn't going to get melted by the heat. So it has to be able to, you have to have it so you can move the heat shrink up far enough away from the solder joint that the heat shrink isn't going to shrink prematurely, because then it won't go over the pin and you won't get the nice, well supported connection that you're looking for. So let's do these as well. There we go. Tin these up. That's done, and don't forget to put all the heat shrink on before you do this. There's nothing worse than finding out, oh no, you've done all this work and you forgot to put the heat shrink on. Trust me, everybody does it. So make a mental note now. Now of course we've got to solder up put a bit of solder on the end of these pins here that we're going to be using for the wires to go on. You have to find the right pin, put a bit of solder on it. Now I know that this one here is the What have I done with my solder? Here we go. So just put a little dab of solder on the top of these pins. Doesn't need to be much, just enough to tin it. That one's a bit hard to get at. Let's turn it around. I've got my pliers in the way. I'm going to do this video again when I get my new bench installed at the workshop so I can get some good angles, and I'll use the commercial board when I redo this video so you can see how much easier it is to use a commercial board than one you've made yourself. But I know some people want to make their own boards, give it a go, do it all themselves, and so hopefully I've shown you what you can do here in this video, some of the pitfalls, some of the extra steps you have to use. Now we've got the video connection goes on the end, so the white one, solder's on here, so we just put a little dab of solder like so. There we go. I think that's good enough. No, it's not. I want to try and get these lined up so there's no bits hanging out the side. Try and get it nice and vertical, and then the heat shrink will fit on nicely. You won't have a big bump to try and get everything over. That's much better. So now I can slide my heat shrink down over the pin and everything. So now you can see that that heat shrink is going to provide some support to stop that wire from fracturing, because it would otherwise bend right down there at the pin. So we won't shrink it up yet because we've got others to do. So there you can see I've got the extension wire on the, if I can get into shot, got the extension wires for the camera connection going onto here. It's all nicely done onto there. I'll heat shrink those later when I've got the other wires on, but we've got a couple more wires to put on. We've got to put on the 12 volt input from the 3-cell LiPo and the input from the UBEC. They have to go in here as well. So now we're at the point where we're going to wire in our UBEC as well, and also our main power lead. And I like to use JST connector for the power from the 3-cell LiPo or your flight pack, mainly because if you're going to use a separate battery, JST is probably what you'll find on it if you're going to use a little separate battery, and you can always make an adapter up for a JST connector here to whatever you want. And I'll show you what I use. I use a JST to balance lead connector, so I can plug it into the balance lead on my 3-cell LiPo pack without having to worry about messing around with the XT60 or the Deans. So here we go. Now what we've got to do here is we've got a lot of negative wires. I actually made a mistake before when I soldered this wire onto the negative, because we actually need to solder 3 wires onto this pin, this negative pin. So we have to bring all 3 together onto the one pin, which means we'll need a larger piece of heat shrink as well. But what I have to do now, of course, is cut some of this, or cut off the lead on the UBEC. UBECs usually have a lead that goes into the receiver and a lead that goes off to your battery. Well, the battery lead, leave that as it is, chop the servo type connector off there on the 5 volt UBEC. Now you may want to experiment with the amount of wire length you have on here, because obviously depending on the design, the physical design of your backpack, this may need to be further or away or closer together, closer to the board. So I'm just going to trim this now. So now we need to put 3 black leads together onto the one pin and find a piece of heat shrink that's big enough to fit over all 3. I'll just tin this wire so that it's not going to go all splaying everywhere when I go to put it on. There you go, it's nicely tinned. Put some more solder on the other black wires. So everything's nicely tinned up. Now I need, as I say, I need to find a piece of heat shrink that will fit over all 3 black wires. That one, this one. I think this one's probably, this piece of heat shrink might be too small. It is. I have to find a bigger piece. Which is why I have this big wad of heat shrink here that I always keep handy, because you can never have too much heat shrink. You can get it from a number of places. Hobby King actually have really good prices on heat shrink, so most of the time I get mine there. Bigger piece. Now you may think, what about the negative here? Won't I need to hook this negative up as well? Well, no, you don't actually, because on these switching becks the negative goes straight through to the other side. So we only need to have the 3 black wires hooked up to the negative, and I'll put a piece of black heat shrink over all of these. Brings them all together nicely. So get all 3 wires roughly the same length, like so. Bring them together. Probably just put a bit of solder on there, just to solder them all together before we even bring them near that pin. There you go. I've got a nice soldered together, bring them over to the negative pin and try and solder them to that pin without them all coming apart again. Actually, see, one of them's already come off, has it? Oh no, yes it has, never mind. Try and solder them all to the negative pin. Chances of that happening with the camera going are pretty damn remote, but I think I've done it. Yep, all 3 wires are now soldered onto that pin, so I can slide the heat shrink down with any luck. There we go. And as I say, I'll shrink all this heat shrink later. But we've got all 3 black wires on. Now we've just got 2 red wires to attach. And the first red wire is the 5-volt output, which, looking at my little diagram that I keep handy, of course, it is the second from the left. So a bit of heat shrink on there. Strip it back a bit. There we go. And it solders onto here. Get rid of the excess solder first. Right, get the granny glasses on again. Right, that's nicely soldered on. Put the heat shrink down. Right, now we have to put the red wire, the 2 red wires, that's one from the input of the SBEC and the one from the JST. They get soldered together and onto the 12-volt pin on the backpack. It's all done. The wiring is complete. The only thing we have got hanging around is this extra lead here from the UBEC. So we can actually get rid of that. We can either chop it off completely or just, in fact that's what I'll do, I'll actually chop it about here. And what I'll do is, to stop it shorting out, I'll fold it over and put some heat shrink on it, and that will take care of it. I could take the heat shrink off the SBEC board and the UBEC board and unsolder it from the UBEC board, but to be honest I can't be bothered. So we use an old trick. Fold the wire over on itself. And slide a bit of heat shrink over the whole thing. I think this heat shrink's too small. It is too small. You need a slightly bigger bit for that. Finding the right size. And one of these little piles of heat shrink can be a bit of a problem sometimes. Here we go. Okay, so now I can heat that up. Should use my heat gun, but no, I've got a soldering iron here, that'll work. And just cut the little end off there, which we don't need. There we go. That will hold it all together. And basically, there is our backpack. There it is. I'll try and get some more light on this. The lighting is terrible. I've really got to get this workshop, this filming studio workshop sorted out so I can get some proper decent looking lighting on some of these projects. So there it is though. That is the FPV Backpack circuit board, all built and ready to go. Here's your channel settings here on this little switch. And your camera plugs in here. That's your little SBEC, and this goes off and plugs into your 3-cell LiPo. Now I did mention about plugging into the balance pack of your 3-cell LiPo. Ooh, here's one I prepared earlier. It's an old battery I've had laying around. And as you know, it's got a Dean's on it, but normally you'd have your XT60 or whatever you happen to use on your own setup. This goes off to your ESC and your motor. And here your JST, you can plug this into here. And then, of course, what you can do is have a female version of the balance port connector, so that can actually plug straight into, I haven't tested this so I won't plug it in, but this plugs straight into your balance lead like that. So there's the feed for your FPV backpack from the same battery that's providing the voltage for your flight system. And that's a really, really simple and most effective way to get the power out of your system without having to make up Y leads and things for your power. But there it is, there's the board. Next video I'll show you how to test it out, make sure it all works properly. We'll hook the camera up to it, and then we'll look at the physical aspects, how we actually make this into a backpack. But suffice to say that if you want to, you can use this board on its own. You can run an extension and a long lead off, so you can put this down the back of your plane if you wanted to, and run the camera off on an extension here so that it's well away from the actual transmitter section if you want to. That's really up to you what you do with it now. And if you have a microphone, if you want to have microphone, you can put those extra two components on there, and then you'll connect up this wire here, down here, will go off to the actual physical microphone, which you'll have mounted wherever you want to put it. That's it. If you've got questions, stick them on the bottom of this video. Now this has been a really rough and rugged, I've done this build video I don't know how many times, and it's never worked out the way I wanted it to, and I'm still not happy with this one. So what I'm going to do is I'm going to do another build video when I get the commercially made boards in, which will probably go a lot easier because you don't have to do things like putting in these little bits of wire along here and running wire through holes and things. You just solder it up so much easier with the commercially made board. But as I say, the pattern for this board will be on the website. The component list, the full build of a bill of materials list, will be on the website, and I'll have some still photos as well so you can get some better looks at how things have gone together here on the website. So thank you for watching, stay tuned. I think the next part of the FPV backpack will be up very soon.